In the last lesson, we learned about functions, how to define them, how to call them, and how to pass parameters into them. In this lesson, we are going to go deeper into two specific concepts: scope and result values. We touched on both of these briefly in the last lesson. Here, we are going to understand them fully because they are the foundation of writing clean, reliable functions. Let's open the terminal and go into our working directory. Let's start with scope. Scope simply means where in your program can a variable be seen and used. Think of it like this. Imagine you write something on a whiteboard inside a classroom. Only the people inside the classroom can see it. Someone standing outside in the corridor cannot see it. But if you write something on a billboard outside the school, everyone, both inside and outside, can see it. In Python, variables work the same way. A variable created inside a function is like the whiteboard, only visible inside the function. But a variable created outside all functions is like the billboard, visible everywhere. Let's create a new file to explore this. Let's name the file scope.py. Let's type some codes there. Let's save. Then let's run it. You can see that the first print worked. Inside function x is equal to 10. But the second print gave a name error. It says x is not defined. This is because the variable x was created inside my function. It is a local variable. It only exists inside that function. The moment the function finishes running, x is gone. The rest of the program cannot see it. Now, let's see what happens with a global variable. Let's update the file. Save. Then let's run it. You can see that both prints worked this time. Inside function, x is equal to 100. Outside function, x is equal to 100. Because x was created outside the function, it is a global variable. It is visible everywhere, both inside and outside the function. Now, here is something interesting. What happens if you have a local variable and a global variable with the same name? Let's try that. Let's save and run the file. You can see inside function x is equal to 10, but outside function x is equal to 100. Inside the function, the local variable x, which is 10, takes priority over the global variable x, which is 100. So the function uses its local variable x. But outside the function, the global variable x, which is 100, is still unchanged. This is very important. When you create a variable inside a function that has the same name as a global variable, you are not changing the global variable. You are creating a completely separate local variable that just happens to have the same name with the global variable. The global variable remains untouched. Now, what if you actually want to modify a global variable from inside a function? To do that, you need to use the global keyword. This tells Python that you want to work with the global variable, not creating a new local one. Let's try that. Let's save, then let's run it. You can see inside function x is equal to 10. Outside function x is equal to 10. This time, both print the same value, which is 10, because we use the global keyword in the function. Then the function modified the actual global variable x, so the change is visible everywhere. However, I want to be honest with you. In practice, modifying global variables from inside functions is not a good habit. It makes your code harder to understand and debug, because any function anywhere in your program can change the value of a global variable without you realizing it. The best approach, and the one professional programmers use, is to use return values to get the results out of functions instead of modifying global variables. Which brings us to the second topic of this lesson, the return values. We briefly introduced return in the last lesson. Now, let's understand this fully. The return keyword does two things. First, it sends a value back from the function to whatever the function is being called. Second, it stops the function immediately. Any code after return inside the function will not run. Let me show you both of these clearly. Let's update the file. Save, then let's run the file. You can see that it printed the answer is 15. Notice that the line print open bracket, open quotation mark, this line will never run, close quotation mark, close bracket, was never printed. This is because once Python hits the return statement, it exited the function immediately. Everything after return was ignored. Now let's look at something important. What happens when a function does not have a return statement? Let's try that. Save and let's run the file. You can see that it printed answer is none. When a function does not return anything, Python automatically returns a special value called none. None is a value in Python that means nothing or no value. It is not zero. It is not an empty string. It is simply the absence of a value. So if you ever see none where you expected a result, it usually means your function is missing a return statement. Now let's look at returning multiple values from a function. In Python, a function can return more than one value at the same time. You simply separate the values with commas after return, and Python packs them together. Let me show you. Let's update the file. Save, then run. You can see lowest score 68, highest score 95. The function returned two values, minimum and maximum. When we called the function, we used two variables, lowest, highest, to receive both values. This is called unpacking. Python matched the first return value to lowest and the second return value to highest. Returning multiple values is very useful when a function needs to give back more than one piece of information. Now let's look at returning early from a function. Sometimes you want a function to stop and return early based on condition before reaching the end of the function. This is a very common pattern. Let's try that. Save, then let's run it. You can see that the file open bracket 10, 2 close bracket printed 5.0, which is a valid division. But calling the function with divide open bracket 10, 0 close bracket printed error cannot divide by 0 because we caught that situation early and returned before doing the actual division. This is called an early return. Instead of letting the program crash with a division by zero error, the program checks the condition first and returns a meaningful message. This is a technique professional programmers use all the time to make functions safe and predictable. Now, let's build a final practice program that brings everything together. Let's create a new file called bmicalculator.py. Let's type the following codes there. Let's save it. Let's run it. Let me enter a name, weight, and height. You can see that the program calculated the BMI and told us the category. Let me run it again and enter invalid values to test the early return. Let me enter 0 for the weight. You can see that it printed the error message instead of crashing. This is a real-world program. It uses two functions that work together. It handles batch inputs with early returns. It returns multiple values and it uses scope correctly. All the things we learned in this lesson. Now, let's push everything to the GitHub. Let's go and check the GitHub. You can see that our new files have appeared in the repository.